Watch the complete playlist on the app Pions. Download the app now.
Question number 1 says calculate the charge carried by 12.5 into 10 to the power 8 electrons. Okay, so our first task is always in physics, write what is given. So here our given quantity is number of electrons. So I am writing here n, which is equals to 12.5 into 10 raised to 8 electrons. These are the number of electrons, right? And what about the charge? Charge on each electron is 1.6 into 10 raised to minus 19 coulomb. Okay, this value you should know by now. Okay, so n is our number of electrons, E is the charge of electron. So what you have to find? You have to find the total charge by all these electrons. This charge is due to one single electron. Let me repeat, this is due to one single electron. You have to find by these many electrons. So we will make use of the first formula of class 12th, which is Q equal to Ne. What is this condition called as? This is called quantization of charge, if you remember. So they can also ask you, give the quantization condition. Quantization means Q equals to Ne, or the total charge on any object is always integral multiple of the basic elementary charge, which is charge of electron. So let's multiply and figure out our answer to 12.5 into 10 raised to 8 multiplied with 1.6 into 10 raised to minus 19. Clear? Now I don't have calculators in my exams, so I have to multiply them. So let's multiply them. First of all, 12.5 into 1.6. So let me do it little fast. 6 5s are 30, 6 2s are 12 and 15, 6 1s are 6, 7. 5, 2, 1, and this will be 0, 0, 1, 7, 3, 0, 1, and 2. So this will be 2, 0, 0, 0. But be very careful, there are two decimal points, so we can put here 2 here. Okay, so it will be 20. 20 great into 10 to the power how much? 8 minus minus 11. Okay, and what's the unit of charge? Our unit of charge is coulombs. So do write the units, otherwise your marks will be gone. This was our question number 1. Okay, great. Let's move to question number 2 in our first chapter. Question number 2. Now pay attention. It says two similarly equally charged identical metal sphere A and B repel each other with a force of this much. Okay, let's repeat the line again. Two similarly and equally charged. Equally charged and similarly means both are of the same shape and equally charged. Let's call this charge as Q and this also Q. Great. Let's call this with name A as they have said and B as this. They both repel each other with the force F equals to 2 into 10 to the power minus 5 newtons. Now, sir, what is this force? This is Coulomb's force, if you remember. And what's the formula for Coulomb's force? 1 by 4 pi epsilon naught Q1 Q2 upon separation R square. Let's assume they are separated by R. So this is equals to Q square by 4 pi epsilon naught R square. Great. Now this is the information we can extract from the first statement. Let's read again last time. Two similarly equally charged identical metal spheres A and B repel each other with a force of this much. Clear? This is the information we got from first line. Let's move ahead and understand the remaining part. A third identical and uncharged sphere. Be very careful. Identical and uncharged sphere C. Let's call this as C. What is the initial charge on C? 0. It is first touched to A. So touched to A, then placed at the midpoint between A and B. Clear? So you are touching this C with A and then you are putting it at the midpoint. Let's draw this scenario. So let's say this is our A after touching it with C. So what happens when you touch a charged sphere with an uncharged sphere? So charges will redistribute. Redistribute means, if let me recall this concept, if there is A with charge Q1, B with charge Q2, when you touch them, the total charge will be Q1 plus Q2 whole divided by 2. This is the charge on A, and charge on B will be Q1 plus Q2 whole divided by 2. Both will have this charge. Clear? This was there in the first chapter itself, concept. So let's use this concept over here. What is the new charge on A? Sir, previous charge on A plus charge on C whole divided by 2. So new charge on A is Q by 2. I hope this is clear. If A is getting this charge, same charge will be for C. So C will also have Q by 2. And finally, B has nothing, one second, B has nothing to do with this because C is touching only A. So B will have still charge of Q. Let's repeat the whole thing. Okay, fast. A third identical uncharged sphere C is touched to A. So uncharged means Q equal to 0. Touching A will give the charges will redistribute equally. And then it is placed at the midpoint. So what is our midpoint? Midpoint here is R by 2. Yeah, previously we took R. So now new separation will be R by 2. Clear? Between A and B. So we are done up till here, this statement. Let's read the last statement again. Calculate the net force, electrostatic force on C. We have to find the total force acting on C. Clear? Let's do this part. So first of all, let's figure out what is the force acting on C. Sir, if you are putting a C here, it will be repelled by charge at A and it will be repelled by charge at B. Repulsion on C due to A will be in which direction? In this direction. It will try to throw it away. If you are having this confusion or doubt, sir, how in that direction? Simply imagine that this is a north pole of a magnet and this is also north pole of a magnet. North pole and this is also north pole. What will happen? This will throw it in this direction and this will throw it in this direction. As simple as that. So A will have a repulsion between A and C that will throw it in this direction. Let's put it as force on C due to A. Now force on C due to B will be in which direction? This direction. Why this direction? Again repulsion. Okay, great. So these are the direction and both are anti-parallel. Anti-parallel means 180 degree. If they are having 180 degree, let me recall the concept. If theta is 180 degree, resultant or the net force on C will be force on C due to A minus force on C due to B, because both are in opposite direction. Now let's try to figure it out. So force acting on C due to A, let me find it here, 1 by 4 pi epsilon naught. First charge on C, Q by 2, charge on A, Q by 2, separation between them, R by 2 whole square. So this will be 1 by 4 pi epsilon naught, Q square by 4. So let's take that 4 down, R square by 4. Let's cancel out this 4 with 4 and our net force acting on C due to A will be Q square by 4 pi epsilon naught R square. This is our net force acting on C due to A. Correct? By using Coulomb's law. As simple as that. Now what will be the force acting on C due to B? That will be equals to 1 by 4 pi epsilon naught. Charge on C, sir, Q by 2. Charge on B, sir, Q whole divided by separation R by 2 whole square. So this will give us 1 by 4 pi epsilon naught Q into Q square upon 2. This extra 2 will go down and here it is R square by 4. When you cancel this 2 with 4, 1 2 will be left which will go on the top. 2Q square upon 4 pi epsilon naught R square. Now some students, they have confusion. Sir, how this 2 went up? Okay. So if you have this confusion, just put a symbol of division. Okay. And then try it. You will get the answer. So I hope this is clear. This is net force acting on C due to A. This is net force acting on C due to B. But question is asking the net force on C. So total will be over here. Let's subtract both. So this will be Q square upon 4 pi epsilon naught R square minus 2 times Q square upon 4 pi epsilon naught R square. Let's go back to the beginning of our problem. Look at this part. So Q square upon 4 pi epsilon naught R square is nothing but 2 into 10 to the power minus 5. Let's substitute over there. So this will be 2 into 10 to the power minus 5 minus 2 times 2 into 10 to the power minus 5. I hope this is clear. Yes, because Q square upon 4 pi epsilon naught square R square is 2 into 10 to the power minus 5. So this will give us 2 into 10 to the power minus 5. 2 2s are minus 4 into 10 to the power minus 5. And eventually, let me write it here, the net force acting on C due to both will be 2 minus 4 minus 2. We can ignore the negative sign, but because, okay, or you can put higher minus lower, doesn't matter. So this will be, or let's keep if you have a confusion in board exams, put a modulus to avoid such problems. Okay, modulus means you can have negative positive both, so it will be 2 into 10 to the power minus 5. Don't get confused if in any other reference books or online, okay, you find this as positive, fine, they must have taken a modulus, okay, or they must have taken higher value minus lower value, doesn't make any difference, but this is the magnitude of the net force acting on C. So by now I think nobody has any doubt. Let's move to question number 3. Question number 3 says two identical charges q each, so two identical charges q each are kept at a distance r from each other. Great. So let's take it as q over here, and let's take another q. Both are q and both are separated by a distance of what? Distance of r. A third charge small q is placed on the line joining the above two charges such that all the three charges are in equilibrium. Very important. This question repeated many times. Many times this question has been repeated. Okay, so there is a third charge small q placed on the line joining the two charges such that all of them are in equilibrium. Very, very important. So this q and this q, they were already in equilibrium, but now when you place the third charge, the whole system goes in equilibrium. Okay. Okay. So question is saying what is the magnitude, sign and position of the charge. So they have not said that the small q you are placing at midpoint. They have not said. You can read the question. Some students blindly take it as r by 2, r by 2. No, they have not said. So let's read one more times and then we will proceed. Two identical charges q each are kept at a distance r from each other, the first two charges. A third charge is q is placed on the line joining the above two charges such that all the three charges are in equilibrium. What is the magnitude, sign and position of the charge q? Now here we use a very important concept. Okay. See, if two people are already stable, clear? So the force acting between these two should be equal to the force acting between this and this. Now some students have a confusion, sir, why you are asking taking the small q and capital Q, this one? You can take this and this also. Yeah, you can take the same thing. Magnitudes are same. So be very careful. Force between the two q's, capital Q's, when there was no small q, they were stable, that must be equal to the force when you place small q here. It has to be equal. If it is equal, then only the system will be in equilibrium. So let's assume that small q is placed at D. If this is D, this will be how much? R minus D. Correct? Okay. So let's first find the force between the two capital Q charges. Let me call it as F1. 1 by 4 pi epsilon naught. First charge Q, second charge Q, separation between them R square. Yes, this was the force when there was no small q. And this force is not getting affected when a small q is introduced, which means it is overcoming this force, right? In a simple sense. So the new force will be F2, which will be equals to 1 by 4 pi epsilon naught Q upon separation. You can take D or you can take R minus D, doesn't matter. That will give you the position from either the first charge or the second charge. Anyhow, you can do. Okay. So don't worry about that thing. Sir, should I take D square or should I take R minus D square in exams? Both are fine. Anyways, the answer will be fixed. Okay. So don't worry about that thing. So let me take it as D square. Clear it is? Great. So here it is F1. Okay. And that is our F2. Now what you have to do, if both are in equilibrium, if the whole system is in equilibrium, what you will do? You will put F1 will be equal to F2. The net force will be equated. Clear? So if it is equated, then we can put here 1 by 4 pi epsilon naught q square upon r square q upon 4 pi epsilon naught d square. Correct? 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught cancels. You left with q square upon r square will be equals to q by d square. Let's cancel one q with one of the q. So you left with q by r square will be equals to small q by d square. Clear? Now to get it in equilibrium, okay, now we will use a concept. Now this is our condition, but in this condition we will make use of concept. What is our concept? To get it in equilibrium, that small q should be placed at the midpoint. So d must be r by 2. If you place it at d equal to r by 2, then we will find the value of small q in terms of capital Q. Clear it is? So if d is equals to r by 2 at the midpoint, if you are putting in that condition, this will be q by r square equals to small q by r by 2 whole square. Okay. And when you simplify it further, let me solve it here this side. So q upon r square will be equal to small q upon r square by 4. Let's take this r square by 4 on the other side. So capital Q, one second, capital Q by 4 will be equals to small q. This is the condition that the charge which you are placing at the midpoint. Now listen very carefully. That is a special condition. If you are placing it at the midpoint, the small q should be 1/4 of the capital Q. Also, the sign should be minus q by 4. The whole system will be in equilibrium only if this small q is negative. Okay, great. The question says, calculate the Coulomb's force between two alpha particles separated by a distance of this much in air. So this much only the information is given. The separation between them is r, which is equals to 3.2 into 10 to the power minus 15 meters. This is our separation. What is the charge on alpha particle? Let me recall. Recently we finished nuclei chapter. Okay. So nuclei chapter tells us that alpha particles are helium nuclei. Sir, what are helium nuclei? Helium is the second element. Okay, second element in the periodic table. How many electrons? Sir, 2 electrons. How many protons? 2 protons. If you remove the 2 electrons from a helium atom, you left with 2 protons inside the nucleus, and that is called our alpha particle. So 2 protons will make it 2 times 1.6 into 10 raised to minus 90. This is the charge on a alpha particle. Clear? Now let's use our Coulomb's law. So according to Coulomb's law, the force will be equals to 1 by 4 pi epsilon naught Q1. Q1 is 3.2 because 2 into 1.6, 3.2 into 10 to the power minus 19 into, this is the first alpha particle, 3.2 into 10 to the power minus 19 second alpha particle whole divided by separation square. Be very careful, it's a square. So 3.2 into 10 raised to minus 15. Again, I am writing twice. Okay, some students they put whole square, that is fine, but writing twice will make it easy for us to solve it. Great. So let's move ahead and cancel out this with this with this. 1 by 4 pi epsilon naught, 9 into 10 to the power 9. In case if you don't know, this is our value of 1 by 4 pi epsilon naught directly. Be very careful with epsilon naught. Epsilon naught is 8.854 into 10 raised to minus 12. But this whole thing is 9 into 10 raised to 9 into 10 to the power minus 38 whole divided by 10 to the power minus 30. Minus 30 goes up. This will be how much? 10 to the power minus 8. And this will give you 9 into 10 to the power 1, which is 90 newtons. That's your answer for this question. Let's move to the next one. Question next says, calculate the distance between two protons. So one proton I am putting here, another proton I am putting here. So P1 proton first, P2 proton second. Calculate the distance between them. So we have to find the value of R such that the electrical repulsive force between both the protons is equal to the weight of the ether. Weight. Now many people, since their basics are not strong, Weight and mass. Mass of proton is nothing but 1.67 into 10 raised to minus 27. I'm just taking 1.66 into 10 raised to minus 27 kgs. Charge of a proton, in case if you don't know, it is 1.6 into 10 raised to minus 19 coulombs. So do we have to remember? Better you remember this for competitive exams. For board exams, they'll give you on the first page of your board paper. But better you remember them. It will help you a lot. What about sir weight? Weight is always from 11th standard. Weight is mass times acceleration due to gravity. And what about acceleration due to gravity, sir? It is 9.8. Clear? Okay. So in case, okay, if they'll give you such question in board exams, they'll give you the value, take G as 10 to make it simple. Okay. Let's start with this. So let's go into the concept. Calculate the distance between the two protons P1 and P2 such that the electrical repulsive force between them. So what is the electrical repulsive force between them? 1 by 4 pi epsilon naught. Charge of first proton, charge of second proton, separation square. This is equal to the weight, mass of proton into acceleration due to gravity. Let's put the values and find the R. So, okay. Now, one method is which usually students do it. They'll plug it here, all the values, and they try to simplify this. My recommendation is, now it's just a choice. My recommendation is take all other variables initially on the other side and keep only the no unknown thing. So what is our unknown here? R square. So let's take everything on the other side. It will be Q1, Q2 upon 4 pi epsilon naught and into M into G equals to R square. Okay, this becomes little easy for us. So that every unknown is on one side. So what is our Q1 charge on first proton? Charge on second proton? And 1 by 4 pi epsilon naught. 9 into 10 to the power 9 straight away. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Mass of proton 1.6 into 10 raised to minus 27. G 9.8. Now you can see here, instead of making it more complicated, I am taking G as 10. Okay, you can take it just to make it simple. Approximate answer you can put here. 1.6 cancels with 1.6. Great. 9 into, now let's focus, minus 38. Correct? And 10 to the power 9 is left. Denominator 10 to the power minus 26. That is equal to R square. I hope this is clear. Now, minus 26 goes up. So let me solve it here. R square equals to 9 into 10 to the power 26 goes up. So 38 minus 26, that is 10 to the power 8 minus, this will be minus 8 minus 6 is 2, 12 into 10 to the power 9. Correct? 12 and 26 is 38. So minus 12. This will be R square equal to 9 into 10 to the power minus 3. That is R square equal to 9 upon 1000. Okay. This is one way. Another way is 10 to the power minus 3. You can take it as 10 to the power minus 2 into something. So basically you can convert it into, okay, decimals. Now, problem is when you will find R, it will be root of this whole thing, 9 upon 100,000, sorry. That is 3 upon 10, okay, 100 into 10 root 10 meters. Let me repeat again, 1000 root will be 100 into 10 and root of 100 is 10. So 10 root 10. So can we leave here? Yeah, fine. Okay, no need of figuring out root 10. Okay, this is our next one. So question says two identical metal spheres having unequal and opposite charges are placed at a distance of 0.90 meter apart in air. After bringing them in contact with each other, they are again placed at the same distance apart. Now the force of repulsion between them is 0.025 Newton. Calculate the final charge on each of them. So final charge on each of them is same. Yeah, doesn't matter because they are not asking our initial charge. So final charge is same on both of them. If it is Q on the first one, second one also is Q. So if final charge is same on each of them, we can directly use the Coulomb's law formula, which is K Q square by R square. Direct. So what is F? 0.025. K is 9 into 10 to the power 9. Q, we are looking for an R square, which is 0.90 into 0.90. So Q square will be equals to 0.025 into 0.90 into 0.90 whole divided by 9 into 10 to the power 9. Let's remove this, you will get here 1000. Let's remove this, you will get here 100. Let's remove this, you will get here 100. 9 and this will cancel out, you left with 10. Okay, so 10 and 10 cancel, 10 and 10 cancel, correct? So what we left with here? We left with here as 25 into 9 whole divided by 10 to the power how many? 3, 4, 5. 5 and 10 to the power 14. So this will give you Q square. So Q will be root of this whole thing. Root of 25, 5. Root of 9, 3. And 10 to the power 14, 10 to the power 7. So this will be 15 into 10 to the power minus 7 coulombs. Okay. Now this is again, I am repeating, this is the final charge on both the spheres. Fine. Let's move to our next question. Question number, next one. It says, pay attention, 3-point charges, 2 microcoulomb, minus 3 microcoulomb and minus 3 microcoulomb are kept at vertices A, B and C. So since they are given in order, this and this, we will also take it in this order. Okay. To avoid any later confusions, let's take it in the same order. So at A, I am putting here 2 microcoulomb. If you are not familiar with microcoulomb, I'll explain again. B, you have minus 3 microcoulomb, and C, you have minus 3 microcoulomb. Okay, I am following the same order. 1 microcoulomb, if you have not seen that before, it is 10 to the power minus 6 coulombs of an equilateral triangle of side length 20 centimeters. So what is each side of this equilateral triangle? 20 centimeter. What should be the sign and magnitude of charge to be placed at the midpoint of side BC? Midpoint means at this point, 10 centimeter away from B and 10 centimeter away from C. You are placing a charge over here such that the charge at A remains in equilibrium. Charge on A remains in equilibrium, which means the total force on A is 0. But wait, sir, who is applying this force? B and C. Simply, if you are placing 3 charges, charge on A will be affected by charge on B and charge on C. So, charge on A, okay, the force acting on A due to B is attractive or repulsive? Sir, attractive. Why attractive? Because this is 2 is positive and minus 3. So, force will be force of attraction. This is force acting on A due to B. Again, I am repeating, this is plus 2, this is minus 3. Plus and minus, attraction. So, attraction will be this A wants to go towards B and B wants to go towards A. But we are finding force on A, that's why we made an arrow in this direction. Sir, what happens if this minus 3 is in opposite, like plus 3, then it would be in the opposite direction, repulsion. It will throw it in there. Sir, why you made this arrow in this particular direction? Why not here or why not here? Because of the force. Because of the two charges. The force is acting always along the line joining the two charges. If we apply the same concept here, this will be the direction of force between A and C. Force between A and C. C is negative, A is positive, so force of attraction. I hope this is clear. Let's find the magnitude of FAB. K, Q1. Okay, let me put the values only. 9 into 10 to the power 9 K. Charge Q1 2 microcoulomb. Charge on B minus 3. Let me remind you again, no negative sign is taken here. In Coulomb's law, there is a modulus here, so negative sign will not be taken. Upon R square. Separation is 20 centimeter. So be very careful, convert it into meters, always standard units. Clear? FAB is this. Sir, what is FAC? FAC will be K. Charge on A. Charge on C. Whole divided by separation square. 20 into 10 to the power minus 2 whole square. Correct? I hope this is clear. So this is FAB and FAB and FAC. Okay. Both are equal? Yes, they are equal. If they are equal, then what will be the resultant? Let's recall a concept of class 11th. Resultant of any two vectors is given by root under a square plus b square plus 2ab cos theta. What happens if they both are equal? Then the same formula will be a square b is equal to a. So a square b is equal to a. So into a cos theta. So this will be root under 2a square plus 2a square cos theta. Correct? This will be the thing. And what if theta is 60 degree? Sir, how do you know the angle between them is 60 degree? Let me remind you, this is an equilateral triangle. So equilateral triangle, angle is always 60 degree. Root under 2a square plus 2a square cos 60 half. Cancels out. You left with root under 3a square. Let me repeat again two important things about this solution. What are these two important things? First thing, both the vectors should be equal in magnitude. Then you apply this. Secondly, the condition here is theta is 60 degree. Then you get this. So this will be root 3a, where a is the any one of the vector because both are equal. Clear it is? So you can use this formula or you can put this complicated thing here and simplify. At the end you will get the same thing. But I am directly using this result. So net force acting on A due to both the charges should be equal to root 3 force. One of the force you can put here 9 into 10 to the power 9, 2 into 10 to the power minus 6, 3 into 10 to the power minus 6 whole divided by 20 into 10 to the power. I'll solve it within a minute. But I hope this concept is clear. So from where I got this extra root 3? From this resultant. Okay, since both the vectors are equal, FAB and FAC, and both are inclined at 60 degree, then we get this particular outcome. Clear it is? So let's remove this. Okay, we have used it. Now, then we will proceed to our remaining part. So this is our total force acting on A. If this is the force acting on A, where will be this force acting? Sir, this force will be acting this side. Sir, how do you know that? See, from 11th standard, if this is a vector and this is another vector, the resultant is always this. Sir, vector is this side and another vector is this side, then where it will be, resultant will be this side. If one vector is this side and one vector is this side, then this side will be the resultant. So it's clear from 11th standard. Okay, this is our resultant. So this is our net force acting on A. Now, if you are placing a charge on midpoint of B and C, this charge should apply a force in the opposite direction. Correct? Which means in this direction. Then only the resultant will be 0. Then only the A will remain in equilibrium. I hope this is clear. Clear? So, first thing, sir, to apply that force, okay, if this is the net force, this is our plus 2 microcoulomb, okay. So, this opposite force should be repulsive, correct? At this point, it should be pointing in this direction, correct? So, this will be the charge on, let's call it as D, should be positive charge. If you are placing a positive charge, then only it will throw it in this direction, right? If it is a negative charge, then it will be along F of A. So we have to put a charge on D in such a way that it should repel this 2 microcoulomb charge. Clear? And repulsion will be upward. So our charge on D must be positive. First thing, charge on D must be positive. But they are asking find the magnitude of the charge. Sign I have told positive. Magnitude, let's see that. So we will make use of a very crucial concept here again. Okay. So our concept is first we will have to find AD. Okay. How do we find AD? Sir, AD, if I draw AD will be perpendicular here. Okay. So in case if you don't know why it will be perpendicular, this is an equilateral triangle. This side equal to this side. This side is equal to this side. So this side has to be perpendicular from our basic concepts of triangles. Okay, perpendicular, since it will form an one triangle, it will be perpendicular bisector. Okay, because it will be, okay, passing through here D, so AD will be median, so it will break these two triangles into two equal triangles, right? So AD has to be perpendicular. So if AD is perpendicular, let's use Pythagoras theorem. So using Pythagoras theorem, AD square will be equals to AB square minus BD square. What is AB? 20 centimeters. So 20 into 400 centimeters square, whatever. We'll convert that into meter later on, minus 100. So you got 300. So AD will be equals to how much? 10 root 3 centimeter. Clear? Root of 300 is 10 root 3 centimeter. That is our AD. Now, if AD is 10 root 3, let's now figure out the force between A and D. So, force between A and D will be very careful, that will be K, or let me put it here directly, because now the concept is clear. This must be equal to K, the charge on A, charge on D, sir, we don't know, upon the separation square. So, 10 in 10 root 3 into 10 to the power minus 2, just to make it simple, and 10 root 3 into 10 to the power minus 2, because centimeter is meters here. I converted. Clear? Now let's cancel out the terms and find the magnitude of Q. This cancels with this. 2 into 10 to the power minus 6 cancels with 2 into 10 to the power minus 6. What we left with here? We left with here 3 root 3, and let's take everything on the other side. 3 root 3, okay, into 10 to the power minus 6 into, let's take this denominator on the left hand side, 10 root 3 into 10 root 3. How much it will be? It will be 10, 10, 100, 100 into 3, 300, 10 to the power minus 4, whole divided by 400, 10 to the power minus 4, equals to Q. 10 to the power minus 4 cancels with this, 400 cancels this. You're left with charge, which should be placed at D, must be 9 root 3 by 4 into 10 to the power minus 6 microcoulomb. Okay, so this is our final answer for this.
Watch the complete playlist on the app Pions. Download the app now.